One, two, three, four.
You're listening to the SKYLIT Books podcast. We're an independent general interest bookstore putting great reads in the hands of people in the Los Feliz neighborhood of Los Angeles. Hosted by resident Skylighters, we're here to bring you new and exciting author conversations, group reads, and bookseller chats. Happy listening.
Hello, listeners, and welcome to the SKYLIT Books podcast. I'm your host, Mike Jeffrey. SKYLIT Books is an independent bookstore located in the Los Feliz neighborhood of Los Angeles, California. We're open every day from 10 a.m. to 10 p.m. and require all customers to wear masks in the store, regardless of vaccination status. We also offer online shopping and curbside pickup through our website, skylitbooks.com, and you can check out our upcoming events on our Crowdcast page, crowdcast.io/skylitbooks. It's my pleasure to be joined by Tim James today to discuss his book, Astronomical, From Quarks to Quasars, The Science of Space at its Strangest. How you doing today, Tim?
Yeah, rocking and rolling. Thanks so much for having me on.
Oh, it's our pleasure. Tim James, the author of Fundamental and Elemental, is a science teacher, YouTuber, blogger, and Instagrammer. Raised by missionaries in Nigeria, he fell in love with science at the age of 15. After graduating with a master's degree in chemistry, specializing in computational quantum mechanics, he decided to get straight into the classroom. He lives in England. I believe you have something picked out to read from the book today.
Yeah, sure. Yeah, I thought I'd sort of go for something from the first chapter, if you just want me to to dive in.
That sounds lovely.
Okay, cool. Right, okay. There are two ways we can analyze other planets and stars. If they're inside our own solar system, we can land probes on them and explore directly. Now, at the time of writing, we've landed 15 times on Venus, 16 times on Mars, sent 2 probes into Jupiter's atmosphere, 1 into Saturn's, landed on the surface of Saturn's moon Titan, put 47 probes onto our moon, 3 onto various asteroids, 2 onto comets, and crashed 1 into the surface of Mercury. And when it comes to freakishness, our solar system does not disappoint. Mercury has a thin atmosphere of helium on its surface and an asteroid crater big enough to swallow Texas. It also has tails of hydrogen gas coming off its surface, like plant shoots reaching for the sun. Nobody knows why. On Venus, the hottest planet, reaching temperatures of 460 degrees Celsius, the rain is made of concentrated sulfuric acid, which boils before it hits the ground and flies back upward. The atmospheric pressure is over 90 times greater than our own, so walking on the surface of Venus would be like walking on the bottom of the ocean, and it snows pellets of lead sulfide rather than ice. Mars, a planet populated entirely by human-made robots, is coated in a fine layer of red rust, with liquid water stored in giant lakes beneath its surface. Its daytime skies are pink, its sunsets are blue, it is home to the tallest mountain in the solar system, Olympus Mons, 2.5 times taller than Everest, and its climate features avalanches and dust storms so big they cover the whole planet. Jupiter, twice the mass of the other planets combined, is also the fastest spinning, with its day lasting only 10 hours. The core temperature is estimated to be around 24,000 degrees Celsius. That's 6 times hotter than the surface of the sun, and it generates the largest object in our solar system, a magnetic field 20 times stronger than Earth's. Jupiter also features the famous red spot, a storm twice the width of Earth, whose colour origin is a mystery, and plays host to about 80 moons, such as Io, the only other place in the solar system with active volcanoes, and Europa, which has a giant ocean of liquid water below an icy shell. Oh, and Jupiter is the only other planet to have Legos, because the Juno probe that flew there in 2016 had 3 figurines of Galileo, Jupiter, and Juno stashed inside. Then there's Saturn with its rings of ice and rock less than 1 kilometre thick, which is so fluffy that if you were to somehow build a bathtub big enough, the entire planet would float on the surface like cotton candy. There's over 60 moons orbiting it, including Titan, which has rivers of liquid methane, that's the fuel used to power school Bunsen burners, flowing over a landscape of solid water. Uranus is a giant ball of ice, mostly composed of water, ammonia, and methane, but it has a hydrogen-helium outer atmosphere, which gives it a blue tint. It's the only planet to orbit the sun on its side. probably hit by another planet in the distant past, and it has close to 30 moons named after characters from Shakespeare plays. Then there's Neptune, the farthest planet, which is also the windiest, with 2,000-kilometer-an-hour hurricanes racing across its surface. Nobody knows how this is possible. It's 4 times the size of Earth, but far less dense, meaning Neptune's gravity is almost the same as our own. So we would actually feel more gravitationally comfortable on Neptune than on Mars. Neptune also has the most unusual rain in the solar system because its atmospheric conditions are just right to crystallize carbon snowflakes in the upper atmosphere to form tiny hailstones made of diamond. And that's just our neighborhood. If we want to observe planets far away, we have to do so using a technique called spectroscopy, invented by Robert Bunsen, the guy who invented the aforementioned burner. It works on a pretty simple principle. Different chemicals absorb and emit different frequencies of light. So if we analyze the light from distant objects, we can figure out what they're made of. When a planet moves in front of a star, the starlight passes through the planetary atmosphere and it gets partially absorbed, depending on what kinds of chemicals are present. So, by noting which frequencies get absorbed by the obscuring planet, we can figure out what the weather is like on a far-off world. And when it comes to weirdness, the rest of the galaxy does not disappoint. Consider the planet 55 Sansui E, which is believed to be made 1/3 diamond right to its core, or the planet J147b, which has rings like Saturn, only stretching 640 times farther out, meaning the planet looks like a pea at the center of a dinner plate. There's a planet called WASP-12b, which is as black as asphalt and egg-shaped due to a slow elongation process pulling it towards its sun. It has about 10 million years left. Then there's COROT7b, which is so close to its sun, it has whole oceans of lava on its surface. Or take Gliese 1214b, which is believed to be made of water, pressurized solid, but so hot it catches fire, making it a planet of flaming ice. There's a nebula called Sagittarius B2 composed of ethyl methanoate, the chemical which gives raspberries their flavor. There's a solar system called Castor composed of 6 suns weaving in and out of each other like a juggling trick. And there's a star called V Hydra that ejects cannonballs of plasma twice the size of Mars into space. There's a planet called Tres 2b, which is the darkest in the galaxy, absorbing almost all the light which hits it. There's a planet named OGLE TR56b, where it rains molten iron. There's a planet named HAT-P7b, twice the size of Jupiter, where the raid is made of aluminium oxide, the main chemical component of rubies. And then there's HD 189733b, a planet where it rains molten glass sideways. Space is very weird.
Thank you so much. That was Tim James reading from his book, Astronomical. I think that was a great selection of passage to read here.
Thank you.
This book in a lot of ways reminded me of, the rare science class I experienced in high school that was just very fun and engaged my curiosity.
Thank you so much. Thank you.
Yeah. I think you just do a great job of picking like very strange details to capture attention, like oceans of lava, rain of diamonds. Yeah.
I wanted to write a book about sort of space that wasn't sort of maps of star constellations and the history of the telescope. I wanted to focus on the weird stuff, wormholes, black holes, aliens, Area 51, the beginning of the universe, string theory, all the kind of the really funky, groovy stuff about space that people are interested in. So I wrote a book with kind of space, the weird bits left in.
Yes. The fun bits. Yeah.
Absolutely.
Can you talk about, you're a teacher by day. Did sort of student questions or your experiences in the classroom, because obviously teaching science, I'm sure there are moments where you're facing somewhat bored faces when you have to teach the math. And then there are probably moments when, you have sort of your tricks in your back pocket to get everyone curious again, like mentioning diamonds falling from the sky of Neptune.
Oh, absolutely. Well, it's teaching space is one of the topics where it's easy. As a science teacher, teaching space, you really don't have to work to make it exciting and interesting. You just basically say what's there, and then nature does the rest. So yeah, you're right. There are some topics where, if you're, say, doing, for example, Isaac Newton's equations of motion, and if you're talking about that, it is a little bit harder work to sort of get people enthused about it. But when you're talking about space, it's easy. In fact, when I was my first year, when I was trained to be a teacher, the head of physics at my school told me something that has always stuck with me. He says, when you're teaching space, if their jaws aren't hitting the floor every 10 minutes, you're teaching it wrong. And that's absolutely right. When I'm teaching space, it really has got to be weird fact after weird fact after weird fact, and space is just so much fun to teach because it really is just lesson after lesson of really cool, interesting stuff, and you just get these fantastic questions, and that definitely informed the book. Definitely informed how I was writing. Is okay, well, what stuff do people actually want to know about?
Yeah, I remember like my junior year of high school, my 11th year, that was like astronomy felt like the reward for making it to the end of physics. Like we just had a unit at the end of the year and it's like, oh, okay, all those equations, and now we get these novelties. And
it's definitely it's definitely sort of one of the cool bits that teach. I like your description of having it in your back pocket. It's definitely one of those things where it's like, all right, we can just have fun now, guys.
Yeah, I wanted to ask you a little bit about your education, because you were raised in Nigeria by missionaries.
That's correct.
And so I'm just curious about like what your schooling experience was like and how you ended up falling in love with science and sort of going down that road.
Yeah, so obviously, I was raised in Nigeria on a missionary compound, but I returned to the UK, as you can probably tell from my accent. I am British. Returned to the United Kingdom. Started school there, and I fell in love with science at about the age of 14, and it was a teacher that did it, and as it often is. For me, it was a guy called Mr. Evans. Even though I know his name was Dave Evans, to me he's Mr. Evans, and Mr. Evans just started pushing me and pushing my sort of brain, and I suppose taking my intellect to places I had never taken it before. It was really him that showed me the universe is worth studying. The universe is interesting, and if you put the work in, you're always rewarded for it. And I was just at the right age, sort of in those kind of early mid-teens where you're kind of starting to think about, okay, who am I? What am I interested in? What do I want to do? And this guy kind of sort of put me on the right track. And then at university, I was very, very fortunate. I had a fantastic sort of lecture at university. A guy called Seishi Shimizu, I also want to name check, and one of the cleverest people I've ever met. He had multiple PhDs, he spoke about 6 languages, and he sort of really, again, stretched my adult brain to its absolute limit. So I was very fortunate to have really inspiring, passionate science teachers who emphasized science is fun. And I just thought, yeah, these guys are great. So I sort of wanted to, I suppose, try and emulate that. And so I went into science teaching myself, and then started writing as well, and thought, hey, this is great fun too.
Was there any kind of conflict for you between sort of being raised in, a faithful environment, maybe by religious parents, and then going down this route? Because I think people assume there's always conflict there, but there doesn't necessarily have to be.
It's a question I get asked a lot, actually, because I was raised in a missionary compound, and I am now a scientist, and so people always want to kind of ask, well, what do you personally think? And I always have to sort of say, I'm not going to say what my own personal view on that topic is. It's a perfectly legitimate question to ask, and I do address in the book. I do address the issue of, well, how does cosmology and religion and the idea of a god link to things like the Big Bang? And I've tried to write it in an even-handed way that doesn't give away what I personally think. I've tried to write it so that you should be able to read it. You get both sides of the argument, and you don't know which side I'm taking. And it's really important to do that as a science teacher, because when I'm sort of teaching, some students in the class will be passionately religious and some will be passionately atheistic. And I'm very conscious of not wanting to influence anyone in either direction. So I just say, here's the facts. I can tell you what the universe is like, but the philosophy and the theology of it, that's got to be your own personal journey. So while it's a perfectly fair question to ask, that's the only question I never publicly answer. So I'm so sorry. I'm going to have to say,
that's a great answer. Yeah.
I'm so sorry. I keep that very, very sort of close to the chest. Only people who know me very, very well know where I stand on that, because I just kind of think everyone's got to come to their own conclusion about that. And it's worth saying there are plenty of scientists who are religious, and plenty of scientists who aren't. There's not necessarily a correlation between scientific knowledge and belief in anything sort of that's, dualistic. Science is the study of the natural world. Religion is about whether there is more than the natural world, and I'm not going to comment on that, I'm afraid. Sorry.
No, don't be sorry. It actually, it's one of, I think, the very endearing characteristics of this book is that you seem to take the position as someone who wants to be a conduit for a lot of the theories and facts that are out there, and make them accessible more so than sort of proposing your own feeling on these things, and with greater depth than like Wikipedia, and making it accessible for a general audience.
Yeah, I want to make sure that I'm letting people make up their mind. I think that's really what a good teacher has to do. And I think the God question and the big bad question, it's a really important discussion, and it should be part of it. When you're talking about cosmology, the origin of the universe, you do have to start asking, well, where did it come from? Is God a good explanation? So I wanted to kind of say, look, here are both sides of the argument. There's interesting things both sides of this debate have to say about it. And there are very, very intelligent people on both sides of that. It's very, very sort of well-educated, well-informed people on both sides of that divide. Here are the arguments. So I give some of the arguments. I talk about Hawking's argument, and there's a theologian called William Lane Craig. I talk about his, and I say, look, here are some arguments. You as the reader, look into this, come to a conclusion. What do you think? But it's up to you.
Yeah, I found that very refreshing, for sure.
Thank you very much. That's really kind of you. I'm glad it came across that way.
Yeah, definitely. One topic that I felt like I could sense your bias a little bit on was the UFO or UAP, whatever the new acronym is.
I'm more happy to talk about that.
Yeah, that one you feel, because 2021 was a big year for alien talk with over here in the States, the Pentagon declassified some things. There was,
I saw those videos and.
What are your thoughts?
It's pretty obvious what's going on there. There's nothing mysterious going on. There's as soon as they came out, there were a whole bunch of people in the scientific community saying, no, there's nothing weird about that. It's pretty obvious what you're looking at. Most of it, I'm not wanting to take away from the thrill of it, but most of it is just tricks of camera perspective. So it's fairly easy to replicate all of it. I know that the three videos you're referring to, there were three clips that were revealed, all three of them. One of them is an aeroplane. One of them, I think, is a balloon, a helium balloon that's been released. I can't remember what the third one is, but there's a very straightforward explanation for all three of them.
Did you happen to watch any of the interviews with the Air Force pilots?
I did. Yeah, absolutely. Yeah, Air Force pilots are very talented people at flying planes. That doesn't necessarily mean they are experts at identifying aerial phenomena. Right. Doesn't mean they're experts in lenses. Doesn't mean they're experts in photography. Doesn't mean they're experts in meteorology. And in the same way, I wouldn't know how. I'm not, criticizing. I wouldn't know how to fly a plane. Absolutely not. But there's a bit in the book where I talk about how there are politicians. Jimmy Carter, former president, saw a UFO. It turned out to be the planet Venus. And Jimmy Carter, he's a Nobel Prize winning guy, and he had a background in science. Very clever guy. Saw something, didn't know what it was. Turned out to be a straightforward explanation. And I think I point out that, look, just because someone is in a position of political or military authority doesn't suddenly mean they're any better at judging what a thing in the sky is. If you see something weird in the sky, that's evidence of something weird in the sky. That's what it is. in order to make the claim that it's an alien, you're talking about one of the biggest discoveries in human history. You need better evidence than just, I don't know what that thing is. Do you know what I mean? Like, you can see something weird in the sky, and yeah, it is interesting. We can't rule it out, and there are some very unusual things that people have seen, but we don't really fully even understand exactly how lightning forms. We don't fully understand it. So before we jump to it's aliens visiting us, let's say, well, can we explain it in a straightforward way first? And then we can say, right, we understand all of this. Now let's look at the stuff we can't understand.
Yeah, exactly. And eyewitness testimony in general is not something that has the best track record for
Unfortunately,
being.
unfortunately not. Unfortunately not. It's exciting, but there's a wonderful experiment done by William Stern, who was one of the early researchers into IQ theory, and he did an experiment where, in the middle of a lecture, he paid two actors to stage a fight. They just stood up in the middle of the lecture. They had a script that they were reading from, and then one of them pulled out a gun and fake shot the other one, and the students were like, what the hell's going on? And a week later he asked them all, right, describe in detail what happened, and there was an absolute plethora of different accounts of what had happened, and who had shot whom and how many people are involved, and people made up memories saying, no, one of them ran out of the room. It's absolutely incredible. He said, no, that's not what happened. But eyewitness testimony and human memory is far more fallible than we like to admit, unfortunately.
Certainly. I mean, I did want to fully believe when one of those Air Force pilots was talking about seeing a massive equilateral triangle structure.
I want to believe.
Yeah,
Absolutely.
rising from the
I remember
ocean.
the X-Files. I want to believe. My God, I would love there to be aliens. It would be so awesome. I totally want to believe. But being a scientist means wanting to believe is not enough.
Right.
You've got to have something more solid than just, it would be cool if so. It's heartbreaking, but it is just, it's the scientist's oath, unfortunately.
Yeah, I really liked. I'd never heard the origin story of the Fermi paradox, which was,
they were just arguing over lunch.
Yeah, just having this argument about the statistical likelihood of life existing elsewhere in the universe, but then Fermi yelling, "Well, where is everybody?"
Absolutely. I mean, statistics. I get asked that question a lot by students. Sir, do you believe in aliens? And I always have to say, well, are you asking me how confident I'm? If you're asking me to put a percentage on it, then yeah, okay, 99% they probably are out there. Yeah, of course, it's very likely statistically that there is other life out there, but no one has ever found strong evidence for it. Because if you see something in the sky that you can't explain that's flying past, how do you know it's not Santa Claus? Why not propose Santa Claus? I want Santa Claus to exist. It's a lovely idea. Seeing something weird in the sky, if you then said, right, that's evidence that Santa is real, everyone would say, don't be ridiculous. The same way, I want aliens to be real, but seeing something weird zipping across the sky is not proof of aliens, sadly.
Yeah, and then you do this nice job too of mentioning that if we work from the assumption that water is necessary for life, there's a possibility that life could exist out there, but it's primarily aquatic and perhaps it doesn't develop technologically.
Yeah, there could be a whole planet where there's loads of life, but they just haven't developed tech because it's very difficult to develop technology if you are a sea-dwelling species, because electricity doesn't tend to behave so well underwater.
Right. I don't know about you. This isn't really a question, but in the state of the world today, it would feel sort of depressing to imagine us as being the most advanced out there. I think that's part of why, like, the idea of interstellar traveling aliens is appealing, to think that like someone has this figured out more than we do.
It would be so reassuring to, yeah, absolutely. No, I agree entirely. It would be, because we look at sort of the planet, and we're overpopulating it, and we're not exactly doing what we should in terms of preserving our oceans and how we're treating the environment. Our climate is not doing too well. We haven't done a brilliant job, not because we're bad or we're evil or we're stupid, but just the sheer nature of there being this many of us. 7 billion people on this planet is difficult to sustain. It would be very reassuring to know actually there's life elsewhere. Someone else has figured it out. There's an advanced species that has learned more advanced technology that isn't reliant on sort of dead plant and fish in the ground for their fuel. So I agree entirely. It would be heartwarming to learn that there really are aliens. So I really hope that there are. I really hope that there are. But until there's evidence, I can't say I believe.
Yeah, I had a hot take that the Pentagon release of UFO files was a sort of psyop to give people hope against climate despair. You know, if aliens are here, then the solution to climate change must exist. Yeah.
Just distract everyone. Yeah, look, see, there's aliens. There's aliens out there.
Yeah. One of the another like sort of endearing characteristic of this book, where you know you're quick with your pop culture references. There's talk of Star Trek in here. How the U.S. government had to acknowledge the threat of asteroids after Armageddon.
Yeah. Good old Michael Bay.
Yeah, good old Michael Bay. Shout out Ben Affleck. But I'm curious what your favorite space movie is.
That's a very good question. So, okay, so are we talking?
Well, two tier. So your favorite, just like pure enjoyment, you know, popcorn flick, and then one that you think actually does a reasonable job of presenting the science of astronomy.
There we go. Okay, right. So in terms of, you know, the best kind of, you know, gold standard of science fiction where it's fully grounded in the science, I'm going to go with 2001: A Space Odyssey by Stanley Kubrick. I think a lot of sci-fi fans would go with that as well. I mean, it was co-written by Arthur C. Clarke, who was a scientist. So 2001: A Space Odyssey, and that's, you know, the grandeur of that. But it's a 2.5 hour long film with hardly any dialogue in it. So it's not like a film that you might put on for fun. So for fun, obviously, I'm a huge Star Trek nerd. So favorite sci-fi movies, I'm gonna say so Star Trek 4, that's all, they go back in time to San Francisco. Star Trek First Contact, Serenity, which is more of a cult film. It's a Joss Whedon film. I know Joss Whedon's name is a little, Joss Whedon's name is a little bit black now in Hollywood, unfortunately, but Serenity I love. And a cult film called Sunshine, directed by Danny Boyle, which not enough people have seen, and it's a total crime. So those would probably be my favorite film. Oh, and Return of the Jedi, of course.
Nice.
That's the thing, because even though I'm fully grounded in science, when I'm watching a fun movie, I don't care how accurate the science is. I'm fine with lightsabers and ion cannons. Bring it on. I love a good fun sci-fi romp. But if you want like quality science, 2001: Space Odyssey.
I want to ask a specific question. Have you seen the movie Interstellar by Chris Nolan?
I have seen Interstellar. Yep.
Yeah. How about the science of Matthew McConaughey falling into a black hole and surviving?
So the science of Interstellar is really interesting. So Interstellar was originally, the idea for Interstellar was actually proposed by a guy called Kip Thorne, who actually just won the Nobel Prize for black hole physics. So he's actually arguably the world's leading black hole physicist. And he actually came up with the storyline for Interstellar originally as a sequel to Robert Zemeckis' film Contact, adaptation of Carl Sagan's novel. And originally Steven Spielberg was going to adapt it. And Kip Thorne actually was on set advising on what's going on in Interstellar. Now, what's happening at the end of Interstellar, which I don't think is actually obvious in the film, because you watch the film and you think, hang on, he's gone into a black hole, how's he surviving, what's going on? Kip Thorne actually explained what's supposed to be happening there. What's happening is, spoiler alert if you've not seen Interstellar, he falls through the edge of the black hole, but he is then saved by an advanced species, which is humans from the future, and they basically trap him in this advanced tesseract thing. So when he goes into the black hole, that when he then arrives in this tesseract, what's supposed to be going on there is that we humans in the future have figured out how to teleport inside a black hole and extract someone and pull them out. Now, I don't think that was obvious from the film. I don't think it made it quite obvious, but according to Kip Thorne, that's the interpretation. But the physics in Interstellar is pretty solid. It holds up reasonably well because Kip Thorne was there advising on it. So Interstellar is another pretty good one. And actually, if any of your listeners, I'm just going to recommend another book. There's actually a book called The Science of Interstellar, written by Kip Thorne, where he talks about the physics in the film and what his role in crafting the story was. It's a really interesting book.
Yeah, that sounds really interesting. I completely dismissed that ending, and now I'm second guessing.
Yeah, so did I. I watched it, and I thought, okay, it was good up to that point. I thought, yeah, the science makes, what the hell is going on? And I thought, okay, that's just ridiculous. He's botched it. But then I kind of started reading it, and I read this explanation from Kip Thorne. I thought, okay, I think the film fails in explaining what is going on. It doesn't quite make it clear that's the ending. Once you know, you're like, okay, that sort of makes sense, but
Yeah.
it doesn't. Yeah, it's not obvious that's what it is. It does look a bit sort of schmaltzy.
Yeah, well, towards the end of his movies, sometimes Christopher Nolan really just falls into the sentimental trap, and
He
just
does. I think Interstellar is him basically trying to do 2001: A Space Odyssey. He's trying to
Right.
remake it, and no one's Kubrick but Kubrick.
Right, exactly. A great Hans Zimmer score, though. I love the organs in Interstellar.
The score's nice. The score is nice. Definitely, I definitely agree with that. Yeah.
All right, one last quick one before you go, because we are a bookstore. If you would recommend some of your favorite books on astronomy.
Well, obviously my own.
Of course.
Please give me your money. Okay, so other great sort of space books. Okay, there's a really great book by Leonard Susskind, American author, called The Black Hole War. Highly recommend that. It's focusing on sort of black holes. That's fantastic. There's a really good book by Lawrence Krauss called A Universe from Nothing, another Californian writer. So Universe from Nothing by Lawrence Krauss is very good. The Black Hole War by Leonard Susskind is really good. What other ones would I recommend? I'm trying. The problem is I've got so many going through my head now. I'm just trying to sort of pick out some other really good ones. There's a really nice book by Neil deGrasse Tyson, which is just called Astrophysics for People in a Hurry. It's quite a nice book. You can read it in about 2 hours, and it's a really small book. It doesn't really go into a whole lot of detail, but if you just want to kind of know like a few pages on, okay, what's this word mean, what's that mean, it's a nice kind of primer actually. So I would maybe say, I'd maybe say that. So Astrophysics for People in a Hurry by Neil deGrasse Tyson. It is a bit sort of, it's a bit sort of light, but it's a good primer. But if you want to kind of really get into the, the nuts and bolts, I'd recommend Science of Interstellar by Kip Thorne, Universe from Nothing by Lawrence Krauss, and Black Hole War by Leonard Susskind, and obviously Astronomical by Tim James.
Of course, can't skip that one. Thank you so
please
much.
Please give me your money, America.
Thank you so much for taking the time today, Tim.
You're so welcome. It's been a pleasure.
Today's guest was Tim James, and we were discussing his book, Astronomical, From Quarks to Quasars, The Science of Space at its Strangest. You can order a copy of the book or any of the others mentioned on today's podcast at SKYLITBooks.com, or swing by and pick them up at the store. Thanks, everybody, for listening today, and have a great day.
Thank you for listening to the Skylight Books podcast series. Please don't forget to visit our website at skylitbooks.com and make sure to follow us on Twitter and Instagram. Also, don't forget to subscribe to this podcast for more author talks and bookseller conversations. You can find us on Podbean, iTunes, and Spotify. Stay safe and healthy, and we hope to see you back in our store soon.